Hello, this presentation is for people who are open to considering a better explanation for the start of our universe. It is a summary of accepted theoretical and proven physics with my logical extrapolations. I was initially looking for an alternate explanation to the standard Big Bang theory, which states that an infinitely dense, infinitely tiny particle magically appeared in a convenient empty space and then decided to blow up. As I will detail, there are a whole lot of things about that theory that even the experts all agree do not work. In the process of solving all those inconsistencies, I was forced to address a number of intimately associated matters, such as the nature of time and entropy and gravity and dark matter. In the end, I hope this presentation, which I will paint for you, gives you a nicer picture that fits together in a pleasing way. Here is the basic theory you have always read. Everything started with the apparently magical appearance of an infinitely dense speck in empty space. Even Calvin and Hobbes saw fit to make fun of it. Note that in all the literature on the subject, there are many glaring deficiencies in the standard Big Bang theory which have not been solved. If all the matter in the universe condensed from a Big Bang, it would have formed an equal number of particles and antiparticles, which would have annihilated to leave free energy again. In other words, there is no explanation for an excess of positive particles over antiparticles, which must have been present for us to be here today. Calculations of this process suggest that it would take an excess of about 1 part in 10 to the 8th of positive matter for the universe to have formed as we see it today. Also, there is no explanation for the presence of dark matter and dark energy, and there is no explanation for the period of inflation, when all the matter and energy instantaneously expanded to nearly the size of our universe today, or why it stopped before everything became totally dispersed. After dealing with the Big Bang problems, I will address the associated entropy, time, and the gravity issues as a bonus at the end of this presentation. All of the following slides show a simplified explanation of the literature I have researched, so there will not be any need for complex formulas. Incidentally, while I may borrow Albert's thought experiment technique, I promise not to get into relativity nor space-time, so you can leave your aspirin in the medicine cabinet. It may seem hard to imagine that our reality includes more than our tiny 3 dimensions in time, but it seems to me no more strange than the fact that our nice tidy atoms of protons, neutrons, and electrons are actually comprised of quarks, antiquarks, gluons, and bosons, and that the particles and energy are predicted to spontaneously appear in the vacuum of space. For the majority of people, time is the thing they check on their wrist. Defining it and explaining it is in reality very much more complicated. The novel extrapolation I will present to you concerning how time works for us seems to solve a whole lot of hanging questions about our universe, as I will explain more in that little bonus section. Of the 4 forces in nature, weak and strong nuclear force, electromagnetism, and gravity. The last one is many orders of magnitude too weak to allow a coherent formulation which includes both the atomic scale and the macro scale of our reality. And not that I am complaining about gravity being too weak. The only reasonable explanation involves the presence of at least one, and according to string theory, which I will comment on later, up to 6+ times extra dimensions. In the next few slides, I will attempt to explain the theory of how a higher dimension could interact with our universe. This ALP is pictured to give you an idea of the immense barrier between our universe and any higher dimension. We're going to talk about gravitons a little later. The evidence for a higher dimension is sufficient that it is worth the extended efforts of the largest particle accelerator in the world to prove its presence. The Large Hadron Collider, and an upgraded model to come, has been firing protons at each other at the fastest speeds the team can muster, and adding up all the resulting particles to see if one gets energetic enough to slip out of our universe. So far, no luck, but a lot of expectation. As a visual image, I think of a high dam holding back an unimaginable energy concentration in the proposed higher dimension. Of course, here the dam should actually be perhaps 1,000,000 miles high, that is 4 times the distance to our moon. But like Hannibal, the scientific community is optimistic it may be able to pass even this barrier. With that introduction, finally we get to the thought experiment I promised you. Physicists and philosophers have considered what life would be like without our third dimension. It turns out that, surprisingly, most of our physical laws would apply to allow life to exist on a two-dimensional world. The proposed scientists pictured here could calculate that there could be an up dimension which could not be reached without exceeding a very high energy barrier. As noted here, this world would run very slowly with very little energy since it would not have gravity. Gravity is the force that powers our sun, which is the source of virtually all of our energy. This, by the way, is my favorite NASA photo, in order to get the gravity profile in exquisite detail of this large crater on the western edge of the moon. A pair of gravitometer satellites had to cross this space hundreds of times at precise intervals while measuring their separation from each other within a distance of only a few millimeters, then stitch the whole thing together. Amazing. Now here's the thought experiment. You may use your thinking caps. The table represents the empty space which must precede any universe formation. At this point, there is no matter present, nor any time dimension. Now, imagine the up dimension as containing a pitcher of water with a large amount of potential energy. That is, gravity times height times the mass of the water. Next, consider what would happen if a random fluctuation or some intervening force caused the pitcher to tip, spilling a flood of water over the empty, flat universe space. From the standpoint of the 2D space, the gush of water would spread almost instantaneously across the universe. That would be its period of inflation, with no relationship to time, or water viscosity in this case, as long as the water was flowing from the high energy upper dimension. When the pitcher stopped flowing, the water would quickly flatten out and become subject to the local time and dimension rules. In this case, the viscosity of water would determine how fast the 2D universe would continue expanding. If the viscosity went to zero, all the water would instantaneously flow off and dissipate. So I believe it is logical that the start of our universe must have begun in exactly the same fashion, with a transient break in the barrier between our space and an extremely high energy higher dimension, with pure energy taking the place of my water example. As long as the barrier was open, the mass of energy could expand without regard to time until the critical barrier threshold was crossed, allowing it to seal again. This would correspond to our inflation period. In the next slides, I will try to illustrate how this scenario would nicely solve all of the unanswered questions left by the Big Bang Theory. First of all, there is a reasonable way that the barrier might suddenly breach. Energy input from gravity, which is known to be able to flow across the barrier since it has no mass, and other high-energy particles, perhaps escaping from other dimensions, could exceed the barrier energy threshold like an overfilled dam, or, if you like, the pressure valve on a steam cooker. Of course, we cannot rule out the possibility of an intervention by a celestial being either. Now, in that scenario, it is easy to imagine that there could have been a period when particles and antiparticles were in contact with that dimension before it closed. Now, if there is some intrinsic property of antiparticles, which makes them a bit more energetic or less stable than our positive matter, a few could have ended up on the other side of the barrier, or perhaps self-annihilated, to explain that missing 1 in 10 to the 8th particles. Now we get to the heart of my thought experiment analysis. Time and light speed limit on all matter are intrinsic qualities of our universe. Once the dimensional barrier closed, these qualities would instantly take effect. The effect of going from near infinite speed to the speed of light would be expected to cause a violent concussion and rebound. This is the same process that occurs when a giant star runs out of fuel and the outer layers collapse until they smash into the core, rebounding in a colossal explosion we call a supernova, which forces the simple atoms and energy to fuse into most of our heavier elements. So this process can nicely explain how a universe starting with high entropy, that is the basic free energy escaping from a higher dimension, or as I don't believe happened, from a tiny speck condensed into material atoms of low entropy to allow our baryonic universe to exist. I will explain later more about time and entropy. By the way, remember that the Big Bang Theory also doesn't explain why there was an inflation period, nor why the inflation stopped. With my scenario, it is also easy to explain the continuing expansion after the end of inflation simply as preserving momentum, just as the debris from a supernova continues to expand indefinitely. Momentum equals mass times velocity. And here there is also a nice explanation for the acceleration of our expanding cosmos as caused by a continuing leak of dark energy and dark matter from a higher dimension. Currently, this is simply accounted for by a sort of fudge factor called the cosmological constant. I will have more to mention on that in a few moments. Of all the original particles created during and after the period of inflation, it has been calculated that an excess of only 1 in 10 to the 8th positive particles over antiparticles would have been enough to create all the baryonic matter in our universe, shown in this illustration. All the rest were annihilated by particle-antiparticle interactions. So I am proposing that if we can accept the higher dimensional concept, a lot of those loose ends are immediately tied up. The original calculations which led to the theory that we could backtrack our expanding universe to an infinitely small, infinitely energetic speck was performed before there was any concept of higher dimensions. Modern string theory includes very convincing mathematics to indicate there must be higher dimensions to get a symmetry of the four basic forces of nature. That is, the weak and strong nuclear force, electromagnetism, and gravity. I will further address the weak gravity issue shortly. As I point out on this slide, there is no difference mathematically whether all of the original energy popped out of a tiny speck or gushed out of a higher dimension. So, you need to ask yourself, do you want to consider our cosmos as starting from a magic speck, or from the real energy that has been calculated to reside in a higher dimension? If you agree that logic suggests the most reasonable origin of our universe involves a gush of energy from at least one higher dimension, then perhaps a new term is needed to replace the Big Bang. I have a suggestion if you are ready. Here's my suggestion. Now, let's get on to my exciting bonus section to address entropy and time and gravity and something else. It turns out that, unlike the hands on your watch, the passage of time is actually related to the rate of dissolution of our cosmos back into diffuse energy. This is what is meant by stating that entropy has inexorably increased since the beginning of our universe. I addressed an explanation as to how the original mass of energy flowing into an empty void could have counterintuitively decreased its entropy state 13 plus billion years ago, when the expanding mass of energy was suddenly slowed to the speed of light. I proposed that the light speed itself was an intrinsic quality exactly like the viscosity of water in the 2D illustration, which took control in a violent shock when the door to the higher dimension closed. This is, to my mind, the best logical conclusion to explain the original formation and current state of our universe. In the next slide, I will explain how the light speed limit continues to affect the rate at which our local universe is returning to the basic state of free energy. All energy transfer is carried by packets of energy we call photons. When matter either absorbs or releases energy, it must do so in very precise aliquots, which we call quanta. Now, you can find a quantum theory summary on the internet without trouble. But basically, when an electron changes its energy state in an atom, it either absorbs or releases a photon at exactly the speed of light. The intrinsic speed limit, noted in the last slide, by the way, is the speed of light. Now, in the next slide, I will comment on what would happen without this speed limit. By the way, this slide illustrates one of my favorite stories about early astronomy and the first person to discover that there is a speed limit to light travel. Ole Romer, back in 1675, accidentally discovered the limit while he was working on a project to help sailors navigate. Unfortunately for him, he was before his time and received nothing but rejection and ridicule when he presented his results to the scientific community. I recommend reading about this entertaining story when you have time. Now, the important point of this is that in the conflict between the force of entropy and all the baryonic matter in the cosmos, we are very fortunate that our space-time does not allow entropic processes to proceed faster than the speed of light. Without this break, everything solid would be able to instantly dissolve into free energy. Because of this limit, it will take about 1 googol of years before the last black hole will finish evaporating. So now let me illustrate this process with a kind of homespun analogy in the next slide. So here, remember, we are considering the light speed limit as the viscosity factor which keeps entropy in check. It can also be considered as inertia in this illustration. If you imagine entropy as a massive force pushing baryonic matter back into oblivion, that is, free energy at absolute zero. In this case, time is the progression of the truck filled with all matter. The speed of light here is the inertia, or you could say the gyroscope, which limits a hybrid truck's speed. The difference between yesterday and tomorrow is that there is actually a bit less baryonic material left in our universe as the truck inches forward. So now I hope I've answered all the questions you might have with a reasonable explanation of the relationship between time and entropy. Now finally, I would like to tackle the problem of gravity and dark matter in the next slides. Now, I'm not claiming any absolute solution, of course, just putting out some logical possibilities for you to consider. In this slide, I'm going to pull everything together for you, which will take a bit of extra discussion, so pull up a chair. Now, it turns out the concept and reality of gravity has been giving physicists headaches ever since Newton. The main problem seems to be that the mathematics seems to indicate there should be much stronger gravitational constant to create symmetry with the other 3 basic forces of nature. Again, these are the weak and strong atomic force and electromagnetic force. Because of this, there is presently no way to mathematically extrapolate processes at the atomic level up to the greater outside universe. This problem is what led to the concept that there must be higher dimensions to account for the weak force of gravity we have. The short name of this is string theory, but it seems that there is little agreement between the specialists on exactly how the extra dimensions work, how large they are, or how many are present. The typical number is 6 extra dimensions plus time. The resolution of the weak gravity dilemma predicts that gravity is actually carried by massless quanta, just like photons, but they are called gravitons. Gravitational effects are also limited to the speed of light, but are said to be able to pass readily through any dimensional barriers into higher dimensions. So the problem these physicists are trying to resolve is that the formulas which work on the atomic level to predict events do not work with formulas we use on the macro level. This is the conflict between quantum mechanics and Einsteinian space-time, which has so far limited the hoped-for theory of everything. We know that some solution must exist since physical processes happen seamlessly across all levels of size. So we might state that the main problem between Newtonian and the atomic scale is that the number for the gravitational constant, as noted above, is much too small. A useful solution might be to combine the currently accepted theory that our gravitational force is transmitted by discrete packets with no mass, which are called gravitons, with the accepted theory that gravitational force can pass without resistance into higher dimensions. This raises the interesting logical thought that it should be possible to use the graviton theory to adjust the formulas. So we put in a number for the gravitational constant, which works both the macro Einsteinian and atomic quantum scales, and assume that this is in fact the correct number. Then we have to explain why we don't feel so much gravity. Well, perhaps the gravitons then are being diverted by the vast stream of connections called strings, which we exist within, as illustrated on the left, connecting our dimension and the higher ones. Note these connections are calculated to be much too small to let anything pass except gravitons. We could propose that the vast majority of the gravitons emitted by a mass are being diffused and absorbed, just like the photons from a street light on a foggy night on the right. To my mind, this is no more of a stretch than the arbitrary addition of a mysterious force called the cosmological constant to explain our accelerating universe. Finally, in the next slide, which is my last, I wonder if the concept of a universe filled with tiny bits of material linking us to a higher dimension can help to explain one more conundrum which has plagued cosmologists and physicists. So here's my last item for you to consider. If we are in a fog of microscopic wormholes and strings connecting to higher dimensions, doesn't that sound like dark matter? Could this all be a solution to our greatest mystery? Just what is dark matter? I hope now you can go back to watching distant galaxies with no more mental distractions about how they got there. I hope I have helped you look at our amazing cosmos in a new and more logical light. Thank you for your attention. Let me know what you think.